Something is coming, not one, but two. Two massive space rocks, one towering like a 30-story skyscraper, the other stretching as long as a jumbo jet, are slicing through the darkness at staggering speeds. They are heading toward our cosmic neighborhood, their paths threading through the vastness with unnerving precision. In observatories across the world, telescopes are locked on target. Radar dishes hum. Supercomputers run endless simulations. In the next hours, they will reach a critical point, and the question hangs heavy: will they pass us by or hit home? The day of two giants. That week, the sky wasn't silent. It was alive. The first intruder, Asteroid 2025 OJ1, appeared as a blip in the data, then resolved into a colossal body roughly 91 meters across. Imagine a tower of concrete and steel, 30 stories high, drifting through the void with unstoppable momentum. Its projected path cut frighteningly close to Earth's orbital lane, at a distance of about 5.15 million kilometers, just a blink in cosmic terms. Not long after, a second traveler emerged, 2019 CO1. Sleeker, smaller, yet still a giant at 61 meters, about the length of a Boeing 747. It was set to skim past at about 6.82 million kilometers. On paper, those distances might seem comforting, but perspective changes everything. The moon orbits only 384,000 kilometers away. These asteroids would pass just 13 to 18 times farther than that. In astronomical scales, that's close enough to make professionals pay attention and the public uneasy. The real shock was the timing. Two objects of this magnitude, passing so near within hours of each other, is a rare choreography. It was like watching two high-speed trains race past the same crossing in one afternoon, each on its own track, each oblivious to the other. They weren't fragments of a single breakup. Their orbits had been shaped over millions of years by countless gravitational nudges from planets, moons, and even the sun's faint pull. This was no arranged meeting. It was cosmic coincidence. For astronomers, it was a jackpot. The same instruments, the same week, the same lighting conditions, but two very different asteroids. A golden chance to compare them in real time. Radar profiles, spin rates, reflectivity. And while the public held its breath, the scientists worked. Every data point mattered, because in the world of planetary defense, knowing an asteroid's exact size, speed, and spin isn't trivia, it's survival. But how do you track two separate celestial bullets moving through space at tens of thousands of kilometers per hour, each on its own trajectory, without losing either? That's where the real magic happens. Eyes on the cosmic highway. The chase begins long before the headlines. High on volcanic peaks in Hawaii, inside white domes in the Arizona desert, and in the silent valleys of California, telescopes sweep the heavens every night. They capture millions of points of light, stars fixed in place. But every so often a point moves. That tiny moving speck can change everything. NASA's Planetary Defense Coordination Office leads the watch, supported by the Pan-STARRS network, the Catalina Sky Survey, and deep space radar arrays like Goldstone. Together, they form a planetary early warning system. Every detection is logged, measured, and tracked. Asteroid 2019 CO1 had been known for years, its path mapped with comforting certainty. But 2025 OJ1 was a newcomer, spotted only recently, quickly confirmed by observatories worldwide. The moment it was flagged, astronomers locked on, measuring its position against the stars night after night, refining its orbit until the margin of error shrank to near zero. The calculations are merciless. They account for the pull of every planet, the push of sunlight, even the faint drift caused by the asteroid's own spin, a phenomenon called the Yarkovsky effect. With enough data, the future becomes clear: when it will pass, how fast, and, crucially, how close. And here, the tension finally broke. The verdict: both would miss Earth. No collision, no sudden, catastrophic curve toward our planet. But safe doesn't mean boring. Close approaches are like live drills for planetary defense. Powerful radar beams bounced off the asteroids, sketching their shapes, mapping ridges and craters, revealing whether they are solid chunks of rock or loose piles of rubble. Light curves exposed their rotation, some steady, others tumbling chaotically through space. This data isn't just for the record books. If an asteroid were ever truly on a collision course, We'd need to know exactly what we're dealing with, its size, structure, and spin, before deciding how to stop it. NASA's DART mission proved we can nudge a space rock, but the right strategy depends entirely on the target's nature. This August double flyby wasn't a rescue mission. It was a test, a proof that the global network can detect, track, and analyze more than one potentially hazardous object at the same time, and do it flawlessly. Lessons beyond August. 2 close passes in 1 week are more than an astronomical coincidence. They are a wake-up call. Lesson 1. Early detection saves time and options. 2019 CO1 gave scientists years to observe and plan. 2025 OJ1 was caught and tracked in just weeks. Both cases prove that whether we have years or days, a coordinated global network can lock onto an incoming object and understand its threat level fast. Lesson 2. Composition matters. By measuring how much sunlight each asteroid reflected, astronomers could estimate what they were made of. A dense, metallic asteroid behaves differently under gravity than a loose pile of rock and dust. That difference determines whether we'd use a kinetic strike, a gravity tractor, or another deflection method entirely. Lesson 3. Gravity leaves fingerprints. Even a pass millions of kilometers away can subtly shift an asteroid's path. By comparing orbital data before and after the encounter, scientists sharpen their predictions for future movements, the kind of precision that could mean the difference between a miss and a direct hit. Lesson 4. This is a planetary effort. The defense net isn't American, European, or Asian. It's human. Data from the southern hemisphere merges instantly with observations from the north. Agencies like ESA's Space Safety Program, the United Nations Office for Outer Space Affairs, and independent astronomers all play their part. The stakes are real. When they faded into the black, nothing on Earth had changed. But our readiness had. Our models were sharper. Our confidence in the system, tested by a rare double encounter, was stronger. And perhaps most importantly, the world got a reminder that space isn't empty. It's a highway, and Earth is always in traffic. They came. They passed. They vanished. 2 unrelated giants crossed our corner of space, leaving behind something far more valuable than fear: knowledge. Their near-simultaneous arrival was rare. The science we pulled from them will last for years. We learned how fast we can react, how much we can uncover, and how far humanity has come in preparing for the unthinkable. This wasn't a story of disaster. It was a story of readiness. And somewhere out there, beyond the reach of our telescopes, the next visitor is already on its way. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.